Hello friends. This video is brought to you by mywayteaching.com.
Let us read the question. In the given figure, PQ is parallel to RS and angle MXQ is equal to 135 degrees. Angle MYR is equal to 40 degrees. Find angle XMY. To solve the question, we need to draw a line AB parallel to line PQ through point M. Then since AB is parallel to PQ and RS is parallel to PQ, implies that AB is parallel to RS. Let us first consider line PQ and AB. The two lines are parallel, then XM is a transversal, and we know that interior angles on the same side of the transversal will be supplementary. So, let us mark angle XMB as angle 1. Then, angle 1 plus 135 degree should give us 180 degrees. Let us calculate angle 1 will be 180 minus 135, which is equal to 45 degrees. So we have angle 1 equal to 45 degrees. Let us mark angle YMB as angle 2. Then our angle M is equal to angle 1 plus angle 2. We have already found out angle 1. It remains to find angle 2. Now consider AB is parallel to RS. Then the alternate angle should be equal. That means angle 2 will be 40 degrees. So we can write angle 2 equal to 40 degrees, and we know that angle M is equal to angle 1 plus angle 2, which is equal to 45 degree plus 40 degree, that's equal to 85 degree, and hence the answer. Let us read the question. If a transversal intersects two lines such that the bisector of pair of corresponding angles are parallel, then prove that the two lines are parallel. Consider the figure on the screen. A transversal AD intersects two lines PQ and RS at points B and C. Ray BE bisects angle ABQ and ray CG bisects angle BCS. Also, ray BE is parallel to ray CG. We have to prove that PQ is parallel to RS. We have already studied many axioms to prove two lines are parallel. Here let us use the converse of corresponding angle axiom to prove that PQ and RS are parallel. If we can prove that angle ABQ is equal to angle BCS, then we would be proving that the corresponding angles are equal, and then that would prove that PQ is parallel to RS. So let us start with the given fact that ray BE bisects angle ABQ. That implies angle ABE is half of the total angle ABQ. Similarly, since CG bisects angle BCS, angle BCG will be half of the total angle, that is half of angle BCS. Also, it is given that B is parallel to CG, then corresponding angles will be equal, implies that angle ABE will be equal to BCG. These two angles are equal. So we write, and now we mark the three equations as 1, 2 and 3. Substitute from equation 1 and equation 2 the values in equation 3. We get half of angle ABQ is equal to half of angle BCS. That means we can take out half common and get angle ABQ equal to angle BCS. But these are corresponding angles. So we can write that PQ is parallel to RS by converse of corresponding angle axiom. In the figure, AB is parallel to CD and CD is parallel to EF. Also, EA is perpendicular to AB. If angle BEF is equal to 55 degrees, find the values of X, Y and Z. Let us start with the lines EF and CD. ED is a transversal, then we can apply the interior angles on the same side of the transversal will be supplementary. So we get angle Y plus 55 degrees equal to 180 degree. Let us solve this further to find the value of Y. We get Y is equal to 180 degrees minus 55 degrees, which is equal to 125 degrees. Now consider lines CD and AB. It is given that they are parallel. Then angle Y and angle X are the corresponding angles and they have to be equal by corresponding angle axiom. So angle X is also 125 degrees. Now let us look at the lines AB and EF. AB is parallel to CD, also EF is parallel to CD, implies that AB and EF are parallel lines. Then AE is a transversal on AB and EF, and we know that angles on the same side of the transversal will be supplementary. So we can write angle EAB plus angle FEA is equal to 180 degrees, which can be written as 90 degrees plus Z plus 55 degrees equal to 180 degrees. Let us solve this further. We get angle Z plus 145 degree equal to 180 degrees. So angle Z is equal to 180 minus 145, which is equal to 35 degrees. So our angle Z is 35 degrees and we have found out the values of X, Y and Z.